Hello, everybody. This is take, I don't know, I lost track. Okay, so I got 3 left on the battery here, 3%. And so I apologize for the last few videos. So I'm going to try to make this as short and sweet as possible. Okay, so we're doing parallel versus perpendicular. Okay, so do you recall how to find the slope of a line? Okay, if you do, then you would remember that you would need 2 points. Okay, and this formula, y2 minus y1 over x2 minus x1. If you're wondering where that m is coming from, remember the slope-intercept form, y equals mx plus b, where your m was your slope. Okay, so that's where this m's coming from over here in this formula. Okay, your m is always your slope. All right, so you can use this formula. I'm going to show you the formula way, and then I'll show you a quick little trick you can use if you get nice points, which we do have nice points above. Okay, so that is what we need to find the slope of a line. What do we know about 2 lines that have the same slope? They're parallel. And what do we recall about the slopes of 2 lines who are perpendicular? There are negative reciprocals. Okay, so what do I mean by that? All right, well, we got 2 lines that come together. Okay, remember when 2 lines are perpendicular, they create a right angle. Okay, and also negative reciprocal. So let's say the slope of this one is 2. Then its negative reciprocal is negative 1/2. Okay, so that's what I mean by negative reciprocal. Okay, in this case we had to put a 1 underneath the 2. We flipped it and we negate it. Okay, so if I had negative 3/5 as my slope, its negative reciprocal, or the line that would be perpendicular to it, its slope would be 5/3. Okay, or if we had a negative 3, okay, was our slope. Okay, well, the negative reciprocal of negative 3 is 1/3. Okay, so that's what it means to be perpendicular as far as slopes go, right? The lines, I'm sorry, 2 lines that are perpendicular, their slopes are negative reciprocals. Okay, and also the symbol to represent, so let's say we had line segment AB, okay, is parallel to line segment, I don't know, we'll go EF. All right, the symbol that goes in there is these 2 straight lines going down. Okay, and as far as perpendicular goes, okay, if you ever saw this symbol, okay, the symbol for 2 lines that are perpendicular is this one right here. Okay, so we have that and we have that. Okay, so if you ever come across that, that's what that means. Here on the left it's saying line segment AB is perpendicular to line segment EF, and up above it's saying line segment AB is parallel with line segment EF. Okay, that's what those symbols mean. All right, now we're going to tie some concepts together. So take a look at polygon ABCD. I call it a polygon because it looks like a square, but we're not too sure. All right, and so down here I'm asking you guys, I said we're going to find, I don't want to find the equation, I want to just find the slope. Okay, and I just want to talk about slopes. All right, so we're going to find the slope of each of these line segments. Okay, so let's do AB. Okay, this point right here is -5, 3. This point right here is 1, 5. All right, and we're going to use the point slope formula, which is m equals y2 minus y1 over x2 minus x1. Okay, so I'm going to make this point x1, y1, this one x2, y2. And finally, plug this stuff in. So y2 minus y1 over x2 minus x1. So we get 5 minus 2 is 3. 1 plus 5 is a 6. And our answer is 1/3. Okay? Let's take a look at AD. Okay, so D, this point down here is 3, -1. Okay, so now I'm going to change this over here. I'm not using this point over here anymore. So I'm going to make this one x1, y1, make this x2, y2. Plug it into this formula again. So m is equal to y2, which is -1, minus y1, which is 5, over x2, which is 3, minus x1, which is 1. So I get a -6 over 2, which is equal to a -3, okay? Which makes sense, right? Because if this is a true square, then we should get perpendicular lines for at least this angle right here, which we are getting, right? How do we know that? How do we know these two lines are perpendicular? Because their slopes are negative reciprocals, okay? Here I got a 1/3. We circle it in red. Down here I got a -3. Those are negative reciprocals, so I know that this line is perpendicular with this line, or line segment anyway, okay? So, that's how to kind of do that the longer way, it's not really longer, okay? But there's a little trick you can use to find the slopes a whole lot quicker. Okay, so I'm going to show you that right now. So the first one I found, what was that? AB was 1/3, right? And then AD is -3. Okay, so if we have a true square, okay, which hint, hint, it is a square, okay, we should see that DC, its slope should be 1/3, and BC, its slope again should be -3, right? Because these two lines here, AB, should be parallel with DC, and AD should be parallel with BC, okay, if this is a true square. So, let's just keep going, okay? So let's take a look at DC, all right? And here's the little trick I'm talking about, okay? So, what you can do is you can count up. So I'm going to count up to this guy right here. Make sure it's even with the side over here. So I'm going to count this spot, which is going to be up 2. I'm going to count this spot up here, which is 6 units. So I'm going up 2 over 6. Remember, slope is rise over run. So in this case, our rise for DC is 2. Our run is 6. And so again, our slope is 1/3. Okay? You can also do it this way as well. Okay? You can go up 1 over 2. Fall right back on the line. Up 1 over 2. Fall back on the line. Okay, so going up 1 over 3, up 1 over 3. So you can verify as well that our slope for DC is 1/3, which we would expect, right? Because we would hope that DC and AB are parallel if this is a true square. And finally, BC, okay? So I'm going to do it this way. I'm going to go down until I reach sea level, pun intended, okay? This line down here. So I'm going to meet right there at that point. So I'm going down. So I'm going -6. So I'm going down 6 over 2. Okay, so down, remember, rise over run. In this case, we have a negative slope, which means we're going down instead. Okay, so our slope is -6 over 2, which is, again, a -3. Okay, which we would expect because, again, we're hoping this is a true square. Okay, so we would expect that if this is a square, this side right here should have the same slope as the other side. Okay, which we do. So, which sides are parallel and which sides are perpendicular? So in this part, we're going to make sure we label these things correctly. So the parallel ones. Okay, so let's do that first. So AB is parallel, okay, to DC. All right. AD is parallel to BC. And finally, I can say AB is perpendicular to AD, and AB is also perpendicular to BC. And then also, DC is perpendicular with AD, and DC is perpendicular with BC. Those are the relationships we have. As you can see, I've written them with the correct symbol in between. Okay, so you're going to start seeing that symbol more often, and it's a great way to kind of shorten things up so you're not writing parallel and perpendicular all the time. Okay, and that is it. Okay, so for homework, I want you to do the same process but for the polygon below. So find the slope of each segment, which line segments are parallel, which line segments are perpendicular. Write them just like I did up here using the correct symbol, and we'll call it a day. All right, made it with 1%. Nice work. Good luck, you guys.